Welcome back to Pilot Scope TV. Ever wondered how a 180-ton metal machine defies gravity and soars through the sky at 500 miles per hour? Today, we're breaking down every major part of an airplane and revealing the engineering genius that makes flight possible. Whether you're an aspiring pilot, aviation enthusiast, or just curious about how planes work, this video is for you. Let's dive in. Let's start with the fuselage, the main body of the aircraft. This isn't just a hollow tube. The fuselage is a pressurized cabin that holds passengers, cargo, and the cockpit. At cruising altitude, you're flying at 35,000 feet where the air is too thin to breathe. The fuselage maintains cabin pressure equivalent to about 8,000 feet, keeping everyone comfortable and safe. The structure uses aluminum alloys or composite materials arranged in a semi-monocoque design, meaning the outer skin bears most of the stress. Stringers and frames reinforce the structure to handle enormous pressures and stresses during flight. Now for the most crucial part, the wings. Wings don't just cut through the air. They generate lift using Bernoulli's principle and Newton's third law. The wing's curved shape, called an airfoil, makes air travel faster over the top surface and slower underneath. This speed difference creates lower pressure above and higher pressure below, literally pushing the wing upward. But there's more. Wings also house fuel tanks that can hold thousands of gallons, control surfaces like ailerons and flaps, leading-edge devices for low-speed performance. At the wingtips, you'll often see winglets, those vertical extensions that reduce drag and improve fuel efficiency by minimizing vortex formation. Flaps extend from the trailing edge during takeoff and landing. They increase both lift and drag, allowing the plane to fly slower without stalling, crucial for safe landings. Let's talk about control surfaces, the movable parts that let pilots maneuver the aircraft. There are three axes of movement. Ailerons located on the outer wings. These control roll the side-to-side tilting motion. When you bank left, the left aileron goes up and the right goes down, creating differential lift that rolls the plane. Elevators found on the horizontal stabilizer at the tail. Elevators control pitch, the nose up or nose down attitude. Pull back on the yoke. Elevators deflect upward, and the nose rises. Rudder, the vertical surface at the tail, steers the aircraft left and right, called yaw. Pilots use rudder pedals to coordinate turns and counteract adverse yaw. Pilots rarely use these controls in isolation. Flying is all about coordination, using multiple controls simultaneously to achieve smooth, efficient flight paths. The tail section contains two stabilizers that are absolutely critical for stable flight. The vertical stabilizer keeps the aircraft flying straight, preventing unwanted yawing. Think of it like the feathers on an arrow, it keeps everything pointed in the right direction. The horizontal stabilizer maintains pitch stability. Without it, the aircraft would constantly pitch up or down. Some aircraft have adjustable horizontal stabilizers that the pilot can trim for different flight conditions. Together, these components create what we call longitudinal and directional stability. The aircraft's natural tendency to return to straight and level flight when disturbed by turbulence. Modern airliners use turbofan engines, marvels of engineering that produce thousands of pounds of thrust. Here's how they work. Air enters the front through a massive fan. Most of this air bypasses the engine core, that's the fan part of turbofan. The remaining air is compressed, mixed with fuel, and ignited. The expanding gases spin turbines that power the compressor and fan, then shoot out the back, creating thrust. By Newton's third law, for every action, there's an equal and opposite reaction. Modern turbofans are incredibly efficient, with bypass ratios of 10:1 or higher, meaning 10 times more air goes around the core than through it. This makes them quieter and more fuel efficient than older jet engines. A single engine can produce 60,000 to 100,000 pounds of thrust, enough to accelerate a 200-ton aircraft to takeoff speed in less than a minute. The landing gear is the aircraft's foundation. These retractable wheels must withstand enormous impact forces during landings, sometimes equivalent to dropping the entire aircraft from several feet. Modern landing gear uses hydraulic shock absorbers and can be retracted into the fuselage or wings during flight to reduce drag. The nose gear steers the aircraft on the ground, while the main gear carries most of the weight. The cockpit is the aircraft's command center. Modern glass cockpits feature primary flight displays showing altitude, speed, and attitude, navigation displays with GPS and weather radar, engine instruments monitoring performance, autopilot systems that can fly the entire route. Fly-by-wire technology where computers interpret pilot inputs. Today's cockpits are so advanced that two pilots can safely manage aircraft carrying 400-plus passengers across oceans. From the pressurized fuselage to the thrust-producing engines, from the lift-generating wings to the precision control surfaces. Every part works in perfect harmony to achieve the miracle of flight. The next time you board an aircraft, take a moment to appreciate the incredible engineering that makes modern aviation possible. Hundreds of thousands of parts, working together flawlessly to transport you safely across the world. If you enjoyed this breakdown, smash that subscribe button and hit the notification bell for more aviation content from Pilot Scope TV. Drop a comment telling us what aviation topic you want us to cover next. Until next time, keep your eyes on the skies.